discussed earlier, we have severe limitations of a simple context handling, and you might at this point in time be wondering as to what a real MCP interaction looks like. We don't have a full-fledged MCP server running yet. We will get to that but in this introductory part, let me show you as to how a basic MCP server would look like. The script that we have here has the most important, or the only class that really is of relevance, is the simple MCP client class. Notice that you see here that it takes in the address, which is the server URL, and this is the server URL of the MCP. Okay. The key method that we're going to that we need to be worried here, or going to be talking about here, is the context and the get context. And the get context has a payload of 1 query, 2 the context keys, and 3 is the number of results that need to be shown out here. So what it does is it takes the query, it takes the context key, and then gives you the top k results. In a real application, this client would make probably a HTTP request, like a post to the MCP server using a /get context endpoint. For this demonstration, I have included a simulated response. As you can see here, there's a dummy response, and you can see in this dummy response out here, it actually chunks it into context units. So the information that the server returns back, MCP server returns back, is in terms of context units, which is provided as content. And in addition to the content, it also gives you metadata, as you can see here. It gives you content, and it also gives you metadata, such as in this case the source or the location or some such stuff. Now imagine the power of being able to ask the MCP server for the context related to Paris, tagged with famous places, that the server would intelligently filter and return the most relevant information. While this is a simplified client and we are simulating the server response, it gives you a glimpse into how the application would interact with the MCP server to retrieve structured and relevant context. As we progress through this tutorial, we'll explore more sophisticated MCP server implementations and see as to how they address the limitations that we discussed earlier. So let me run this, and when I run, and I assume that this simple MCP client is running on localhost 8000, and the query that we're passing out here is, tell me about the famous places in the capital of France. The MCP client takes the get context and gives me context units, which is a whole bunch of context units that you can see here. It then gives me the context content as well as the metadata of each of these context units. So let me run this code, and my query here is, tell me about famous places in the capital of France, and we have contacted the MCP client, MCP. The MCP is getting simulated here as an simple MCP class, and this takes in this query and context and returns out to me context units, which has both content as well as metadata. Let me change the output and run this. Okay, you can see here it has retrieved three context units. The first context unit has the content. Paris is the capital of France, and the metadata is source encyclopedia. Now, obviously, we're simulating it out here, and this is not a real MCP server. But in the wild, the MCP server will do this plumbing work for us behind. We'll get to that in a little while from now. But you understand the power of an MCP server. The MCP server, when given the context, is able to plumb into various sources, chunk these sources into context, into various pieces of window chunks that are of the size that the LLM can take. It can give you both the content and the metadata. We can then use the content and the metadata along with our query and pass it progressively. We can pass the context unit 1, which fits into the window, and then context unit 2, which fits into the window, context unit 3, which fits into the window, through a loop into the LLM, and the LLM would be able to fetch out the relevant data. So if you've got this, in the next session we'll talk about the shortcomings of RAG, and we'll actually do a simple implementation of RAG. So see you there.